In this video, we'll go over the 2022 National 5 Maths Paper 2. So question 1, expand and simplify this expression. So it would just be 3x times 2x squared, so 6x cubed, and then 3x times 5x, and then 3x times minus 1, and then we would just repeat the same thing for the minus 2. So that would be minus 4x squared minus 10x plus 2. And then we just collect the like terms. And that would be the simplest form. A company's annual profit at the end of 2021 was £215,000. The profit is expected to increase by 3% each year. Calculate the company's expected annual profit by the end of 2025. Give your answer correct to the nearest £1,000. Okay, so because it's an increase question, it would be 100 plus 3 over 100, and that would give you the multiplier. So that would be 1.03. And then from 2021, so the end of 2021, to the end of 2025, that's exactly 4 years. So we would just raise that to the power of 4, and then we would multiply it by this quantity. So that would give 241,984.39. And then to the nearest £1,000, it would just be 242,000. A concrete gatepost is made in the shape of a cuboid with a sphere on top, and then we've got information about the cuboid. Calculate the volume of concrete needed to make a gatepost. So we're just trying to find the volume of this shape. So let's start by finding the volume of the cuboid. So that would just be L times B times H, so length times breadth times height. So the height is just 2.4 minus the diameter of the sphere, so minus 0.4. So that would be 2 meters. And then this length over here is just the same as this length because it's a square-based cuboid. So that would just be 0.48 times 0.48 times 2. So that would be 0.4608. Now let's find the volume of the sphere. So Vs equals 4 over 3 pi r cubed. And you get this formula in the formula sheet, by the way, so you don't need to memorize it. So the radius is just half the diameter, so r equals 0.2 meters. And then you would just plug that into the formula. So 4 over 3 times pi times 0.2 cubed. Excuse me. So that would be 0.0335. double check that because I didn't write times. Yep. And then we just add the two answers together. So total volume. So volume of gatepost is volume of sphere plus volume of cuboid. And then we just add the two together. And that gives 0.4943. And that would be in meters cubed. Okay, question 4. Moira buys 4 mangoes and 3 apples at a fruit shop. The total cost is £4.25. Write down an equation to illustrate this information. So if we let the price of a mango be M, and then A is the price of an apple, so A equals price of an apple, then it would just be 4M plus 3A equals 4.25, £4.25. And then this equation would be 5M plus 2A equals 4.7. And then part C, calculate algebraically the cost of a mango and the cost of an apple. So we're just trying to find M and A. So we've got two equations. And then we just need to solve these simultaneously. So I'm just going to multiply this one by 2 and this one by 3. And that will make these terms equal. So we end up with 8M plus 6A equals 8.5. And then the second equation would be 15M plus 6A equals 14.1. And then we'll just subtract this equation from this equation. So I'll just label them 1 and 2. So we're just doing 2 minus 1. And that would give 7M. The A's cancel, the 6 A's cancel. And then 14.1 minus 8.5. So that would be 5.6. So M equals 5.6 divided by 7. So that's 0.8 or 80 pence. So I'll just write 0.8 actually. And then to find A, we just plug this back into one of the original equations. So I'm just going to use this one. So that would become, so let's write that actually. So plug into original equation. So that becomes 4 times 0.8 plus 3A equals 4.25. And then we get 3A equals 4.25 minus 4 times 0.8. So that's 1.05. And then A is 0.35. So A is 35 pence. And then M is 80 pence. A school netball team recorded the number of sit-ups each player completed in a minute. The numbers for the 7 players were, and then we've got the data on that. calculate the mean and standard deviation of the numbers of sit-ups. So the mean would just be X bar equals, and then we just add up everything. And then we divide by the number of numbers. So that would just be 7. So let's see what that gives. So 29 plus 27 and so on. So that would be 26 sit-ups. And then to find the standard deviation, we just draw the table that we would normally draw. So X, and then X minus X bar. And then we would just square that. So 29. Okay, so X minus X bar is just these numbers minus the mean. So that would be 29 minus 26, so that gives 3. This one would be 1. And then we just carry on filling out this column. And then we just square these numbers. So that means that the sum of this column would give us sigma of this expression. So this is part of the standard deviation formula. So let's just add up the numbers. So that's 120. And this just means sum of, by the way. So essentially, we're just summing up all of these numbers, and these are the numbers. So the standard deviation would just be the square root. So square root of X minus X bar squared over N minus 1. And then that was 120. And N minus 1 is just 7 minus 1. So N is the number of numbers. So it would just be 6. So root and then 120 over 6. And that would be 2 root 5. And then because we're going to do a compare question after that, we should change that to a decimal, actually. So that would be 4.47. Okay, part B. Some players in the school's hockey team also recorded the number of sit-ups they completed in a minute. Their numbers gave a mean of 29 and a standard deviation of 3.2. Make 2 valid comments comparing the numbers of sit-ups of the players in the netball team and the hockey team. Okay, so the mean of the players in the hockey team was 29, and this one was 26. So we can say that on average, the players in the hockey team did more sit-ups per minute. So did more sit-ups than the netball team. And then the standard deviation was lower for the hockey team. So the netball team had 4.47, and then the hockey team had 3.2. So their data was basically less varied than the netball team's data. So we can say that, but their number of sit-ups was less varied. So those are the two comments. This is the first one. So it's just the on average stuff. And then the stuff about variation is the second comment. Okay, question 6. The diagram shows triangle FGH, and then we've got some information about that. Calculate the area of triangle FGH. So the area formula is just A equals a half AB sine C. And this is used when you've got two sides and the angle between them, which is exactly what we have here. And you get this in the formula sheet, by the way, so you don't need to memorize it. So it would just be A equals a half 25 times 32, and then sine 58. So 0.5 times 25 times 32, and then sine 58. And that gives 339.2. Solve the equation 4x squared plus 2x minus 7 equals 0. Give your answer correct to two significant figures. So whenever it says give your answer correct to, and then you've got an approximation, that's a hint to use the quadratic formula. So you get that in the formula sheet, and it's just minus b plus or minus root b squared minus 4ac over 2a. So for this equation, that would be minus 2, so that's the b value, plus or minus root 2 squared minus 4 times 4 times minus 7, so that's c, over 2a. So a is 4, so it would just be 8. And then we'll start by taking the plus sign, and then we'll do the minus to get the two solutions. So minus 2 plus, and then root 2 squared minus 4 times 4 times minus 7 divided by 8. So it's two significant figures, that would be 1.1. And then we'll just change the sign to a minus. And that gives minus 1.6. So those are the two solutions. A train tunnel has a circular cross-section with a horizontal floor. So that's the cross-section. And then we've got a diagram of that. Calculate the height of the tunnel. So we're just trying to find this length over here. So it's made up of two lengths. We've got the radius over here, and then we've got this height over here. So the radius is just 2.9 meters. So that would be 2.9. And then to find this length, we would just use the Pythagorean theorem. So this would be 2 meters because the whole thing is 4. And that exactly splits this in 2. So that's 2, that's 2. So we've got a right angled triangle, and then we can just use Pythagoras to find this length. So it would just be x equals root 2.9 squared minus 2 squared. So that gives 2.1 meters. So the total length would just be 2.9 plus 2.1. And that would be 5 meters. Okay, question 9. Solve the equation 3 sine x plus 4 equals 6 for x is less than or equal to 360 and more than or equal to 0. So whenever you've got a trig function in this form, you would start by rearranging to make sine x the subject, or whatever the trig function is that you're working with. So 3 sine x equals 6 minus 4, so we just move the 4 to the other side. And then that would give sine x equals 2 over 3. And then we just take inverse sines of both sides. So shift and then the sine button, that gives you the inverse sine, and then 2 over 3. So that's 41.8 degrees. And then we just draw the cast diagram as usual. So SATC. And because sine is positive, so it's 2 over 3, it would be this quadrant and this quadrant. Those are the quadrants where sine is positive. And then you just put the value into those quadrants. So 41.8, and then 41.8. And then we just measure it from the initial line. So this is the initial line. And then we just measure these angles counterclockwise. So that's the first one. And this would be the second one. So we just go up to these lines in the diagram. And then that one would be 41.8 degrees. And the other one is just 180 minus 41.8. Because if you think about it, all the way up to here, that would be 180. So this would just be 180 minus that part. So that would be 138.2. And those would be the two solutions. An attraction at a theme park has a carriage attached to an arm. The arm swings from A to B along the arc of a circle, center C, as shown in the diagram. Calculate the size of the reflex angle ACB. So the reflex angle would just be this angle over here. And we're given the arc length, so that's 69.4. And that's the major arc AB, so it would be this arc. And we're trying to find this angle over here. So we would just use the formula for finding the angle. So theta equals arc length over circumference times 360. And the circumference is just 2 pi r, or you can say pi d in terms of diameter. So that would just be 69.4 over 2 pi times the radius, so that's 15, times 360. And you don't get this in the formula sheet, by the way. So all of the sector formulae, you have to memorize those. So 69.4 over 2 times pi times the radius, and then times 360. So that gives 265.1. The diagram shows a cuboid A, B, C, D, E, F, G, H. Calculate the length of EC, the space diagonal of the cuboid. So we're given these side lengths, and we're trying to find this diagonal over here. So this is just the 3D form of Pythagoras' theorem. So there's actually two ways to do it. The first one is where you just square the lengths that you're given. In other words, the lengths that make up the space diagonal. So this diagonal is actually made up from these lengths over here. And then you would just square root that to get this length. So it would just be EC equals the square root of 24 squared plus 6 squared plus 8 squared. And you can see why it's called 3D Pythagoras, because it's basically the same as Pythagoras' theorem. So that gives 24 squared plus 6 squared plus 8 squared, and that gives 26 centimeters. So that's the first way of doing it. The second way is to do it in parts. So you'd start by finding this length, this diagonal over here. So that would be EG, using this right angled triangle. So EG is root 24 squared plus 6 squared. So that gives 24.739. And then you would just use that to find this diagonal over here. So you just use this right angle triangle over here. So that would be a right angle there. And then we've got this length over here, and this one's just 8. So that would give EC equals root 24.739 squared plus 8 squared. So root answer squared plus 8 squared, and that gives 26 again. So both of these methods are valid. I would stick to this one, actually, because sometimes you can make a mistake with this one if you don't include the right lengths to find the diagonal. Simplify 2ab plus 6a over b squared minus 9. So we start by factorizing the numerator and the denominator. So it will just be b plus 3. And then this would just be a difference of 2 squares. So b minus 3 over b plus 3. And then we just cancel the common factors. And that leaves us with 2a over b minus 3. Simplify sine x plus 2 cos x over cos x. So that would just be sine x over cos x plus 2 cos x over cos x. And that's just how you divide two terms by one denominator, by one term in the denominator. So it would just split up like this. And then that would be tan x. And that's from this trig identity. So tan x equals sine x over cos x. And the other trig identity you need to know is sine squared x plus cos squared x equals 1. That doesn't feature in this problem, by the way, but these are the two identities you need to memorize for trigonometry. And you don't get these in the formula sheet. And then this would just become 2. So the cos x's would cancel, and then you get plus 2. And that would be the simplest form. The width of a river is represented by BC in the diagram below. AB represents a tree on the riverbank. And then we're given some information about the diagram. Calculate BC, the width of the river. So we're trying to find this length over here. And I can see that if we have this length over here, that would allow us to find BC using SOHCAHTOA, because this is a right angle triangle. So we're just trying to find AC, essentially. So we've got this length over here. And we've got the angle opposite AC. So we just need this angle over here, which is opposite to this side. And then we'd be able to use the sine rule to find AC. So I can see that this angle is just 180 minus 28 because we've got a straight line. So that would be 152. And then that means this is just 16 degrees because we just do 180 minus this, and that gives us this angle. So the sine rule would just be, so let's label the sides actually. So that's little a, that's little c, that's little d. So it would just be d over sine d equals a over sine a. So those are the two sides we're using. So we don't need c over sine c. And then that becomes 15. Yeah, so 15 over sine 16. So a over sine a equals d over sine d. So sine d is just sine 12. So that's d. And then we just rearrange that to find d. So d equals 15 sine 12 over sine 16. And if you can't see why this is, by the way, I'll just write out the working out over here. So if we multiply both sides by sine 12, that's how you move it to the other side. That would become 15 over sine 16 times sine 12 equals d. And then if we write this as a fraction, so sine 12 over 1, we can just multiply the two fractions straight across. So 15 sine 12 over sine 16 times 1. Okay, so let's see what that gives on the calculator. So 15 sine 12 over sine 16. 11.314. And it's always a good idea to include as many decimal places when you're doing an intermediate step, in the problem. So we'll just include 3 decimal places for this. Okay, so that gives us length AC, and then we can just use SOHCAHTOA to find length BC. So we've got the angle, and then we're trying to find the adjacent to the angle, so that would be A for adjacent. And then we've got the hypotenuse as well. So it would just be CAH. So cos 28 equals adjacent, that's BC, over hypotenuse, that's 16. And that's just from SOHCAHTOA, so CAH. And then that gives BC equals 16 cos 28. So 16 cos 28. And that gives 14.1 meters.